thank you for joining us in this webinar about CYPE 2023, in particular about the new features related to CYPE Architecture, CYPECAD and CYPE Connect interoperability. My colleague is Alfonso Solac, is the Digital Marketing Director. Hi, Alfonso.
Hello, Marta.
And my name is Marta, as you know. Oh, maybe you don't know, but I'm Marta. And if you have any questions, any concerns, whatever you need to know about this presentation or anything else about CYPE, please contact me at marta.franca@cype.com. You can also ask questions through the chat in this webinar, during the webinar. And we will try to answer all the questions that you have during the session. I wanted to show you as well how to download CYPE Connect. You just need to go to our platform, BIMserver.center. It's in English, as you can see. And then after registering, you can go to our store and you'll find many programs here, including all the programs that we are going to show you today. And if you want CYPE Connect in particular, it's here. You just go there, or any other software, any other programs, and you'll find the downloading button here. Here it says in Spanish. I don't know why. But you'll have it in English, and then you can go to the website through this link here, this button here, and it will take you to the English website for each individual programs that you want to find. And that is, oh, sorry, not thank you yet, but I'm gonna let Alfonso carry on with the presentation. And then after that, I will show you again my email address and how to download our programs from BIMserver.center at the end of the presentation, just in case some people start or join us a bit later than now. So, Alfonso, whenever you want.
All right, thank you, Marta. Could you please confirm that you can see my screen?
Yes.
All right, so yeah, let's begin with this third session. This is the third session showing the new features of the CYPE 2023 version, okay? So during the past week, starting on June 14, we started with a global overview, a global presentation, taking a look on the main features and enhancements implemented in our software. And then we had a session showing how to render SIP beam models with Twinmotion, using one of the new features that was implemented during this launch. And today is the third session, June 21st. And as Marta said before, we'll talk a little bit about this interoperability that we can have between CYPE Architecture, CYPECAD, CYPE Connect, because doing an example, connecting the architectural model with the structural model, we will see some new features that were implemented in this connection between programs. And then in the end, when we design a connection at CYPE Connect, we also see one of the new features that we have at CYPE Connect. Okay, so today we have two sections. We have one during the morning, another one during the night, as we had in the past sessions. And you can then find the recordings about these videos that we are recording, these presentations, they are recorded in our main channels and on YouTube. So search for CYPE International, and you find this content available tomorrow or during this week. Okay, so as Marta said before, today we have three softwares. Okay, CYPE Architecture, it's going to be our 3D architectural modeling program. So it's a free software that you can download from here, from the BIMserver.center store. Then we have CYPECAD. So we will use the architectural model developed at CYPE Architecture to create the structural model at CYPECAD. So we import the architectural model into CYPECAD and then design our structure using the geometry and the information that was introduced in our project with CYPE Architecture. So the design is going to be here, the design of the structure is going to be here, get information from here. And then when we design this structure according to one specific code, it's going to be a steel structure. We will export this structure to BIMserver.center, and then we will import this structure at CYPE Connect, and then we will design the connections. So during this presentation, we designed just one. It's just an example, but the idea is this is the workflow. So it's a workflow, a very flexible workflow that you can use alone. You can use in one unique computer, for example, or you can invite 2 or more people to work with you, and each person can work with a different software, and then you can work as a team using the BIMserver.center platform. Okay, so let's begin just showing a little bit the model that we will see today. It's a very simple model. Okay, we are here at the CYPE Architecture main interface. So yeah, it's a building with 3 floors and a basement. Okay, so we have here a basement. It's interesting because the architecture was developed, and here we have some layers. Okay, some layers which were used to classify the main elements that we have in the building. So if we unselect everything here, let me select just the empty layer. So just showing what we have here, we have some slabs, okay, some different types of slabs. Then we have some columns, okay. In this case, they are architectural columns. So they are this is the first geometry of the column. This column, it's not designed yet. So it's just a simple geometry. We don't know the rebars. We don't know the design, the behavior of this column yet. So we are in an architectural phase yet. Then we have some beams, okay, different types of beams. Let's put the slabs here, for example, in transparent. It's gonna be easier to see the first approach to our structural model, okay. Then we have some curtain walls, we have some stairs, we have some railings, we have different types of walls, we have the carpentry, we have the guarding, we have the furniture, okay. All the architectural elements that are important to a project that are part of our BIM model that can be used to different purposes when we are working with BIM technology, okay. In this case, for us, it's very important to know where are located and what type of elements we have in some situations, okay. For us, it's very important to know, for example, the position of the columns. Let's select here. It's important to know the position of the columns, the position of the beams, the position of the slabs, and the position of the walls, okay. This information is important to us because we will export this model, and then this information will be imported at CYPECAD, and we will classify these elements as structural and non-structural elements. We will add more information related to the sections of these elements. We will transform some walls in loads. So we will do a lot of, we'll add more information, more layers of information to each element to design or to develop a structural model based on this architectural model, okay? So you can imagine, as we have here, for example, the activating here the guarding, that this basement wall, it will be transformed in a structural or reinforced concrete wall. So it's going to be a structural wall. These walls, these internal walls, they will be transformed in loads, in linear loads that will be part of our structural conception, okay? The columns, we will add more information related to these columns. The beams, the same situation, okay? So just showing here, when we create one model here, it's important to work with types here at CYPE Architecture. So as you can see, my walls, we have here 4 types of walls: interior walls, 2 types of facades, and 1 basement wall. And each element has different information. So it's important to know this reference, this name. So when we assign one of these names here, when we import the architectural model at CYPECAD, we will use these names as reference. Okay, so it's important to create these types here. The same situation is going to be with the different types of floor slabs and also the columns and beams. Okay, so you can see that in this model, it's a very simple model. We have just one type of column. It's a squared section column, so rectangular, with dimensions of 24 by 24. And then we have two types of beams, 20 by 40 and 10 by 25. So these two types of beams, we'll add more information to these beams. We'll characterize the sections, and maybe in the future, these beams must be updated because maybe this section is not correct. So this is a first try. This is the first interaction. This is the first moment that we add information to our model. Maybe in the future, we'll realize that the sections must be bigger or smaller than this, and then we must update this information according to the design criteria that we develop at CYPECAD. Okay, so this is the main concept that we must know here at CYPE Architecture. And knowing that, we just have to export this information to the folder that we've created before at BIMserver.center. Okay, so I'll share this information. I'll add a name for that architectural model, and once this information is exported to BIMserver.center, we will import this information at CYPECAD. Okay, so just let's wait just a little bit here just to finish this process of exporting information. It's important to know that when we select here some layers, okay, those layers that are selected here are the layers that will be exported when we press the button share. Okay, so if you have everything unselected, the project is going to be empty. Okay, so watch out with that, because according to the selection, you have the information at BIMserver.center. Here you can see that the information is we are uploading information to the cloud, but working locally in the same computer, we don't have to wait to start working with CYPECAD. Okay, so I'll jump here from CYPE Architecture to CYPECAD, and I'll start a new project here at CYPECAD. Okay, as you can see, I'm already connected with my account. I'll select a project, actually the project that where we exported the information. It's called the modular building. Okay, so I'll click here. I'm now connected. I'll accept, and now I will start importing the information from the architectural model that was exported from CYPE Architecture to BIMserver.center. Okay, so let's accept it, and CYPECAD will start reading the information that we have in our model. Okay, so in our model, we have this CYPE architectural model, but we also have other layers of information, layers that were created to run thermal and acoustic analysis. They were created with two different applications, two different softwares. OpenBIM analytical model, with this software we generated the analytical model from the BIM model, and OpenBIM construction systems, where we add more layers of information to the walls, to the different thermal and acoustic information to our system. Okay, in this situation, we will not import this information. For us, it's not important. So for us, it's important just the architectural model, because from now on we will add more structural information to these elements that we will import from the architectural model. Okay. This is not the case, okay, but if you are using different softwares from different software developers, let's imagine you are using Autodesk Revit or ArchiCAD, or I don't know, any other BIM modeler. If you don't have the same reference system, so you can use this button here to manage the difference that you can find between the difference between different softwares. Okay, so here you can manage the problems related to levels, problems related to distances. So to find the right place to import your architectural model before you start creating your structural model. Okay, this is not the case because we are using the same system. So CYPE Architecture and CYPECAD have the same reference system. There's no problems here. So let's click on next, and then we'll start importing information. Okay, as you can see here, this is new. Okay, actually part of this is new, part it was in the past versions. Okay, this is the menu where we can import the different levels that we have in our beam model. Okay, this information, so the elevation above ground, this information was imported, was recognized by CYPECAD when the program imported the model created at CYPE Architecture. Okay, this information actually was introduced here at CYPE Architecture at this menu here, at the architectural menu, in the levels button, in the level management panel. Okay, so this information, these names, and also these numbers, okay, this elevation numbers, they were introduced here. And if we use here, for example, a side view, we can see those levels. Okay, the basement, the ground floor, the first floor, the second floor, the roof. In this case, I've created one level that I called railings. Okay, and then the rooftop. Okay, so those are the levels that we have in our architectural model, and we will have the same levels now that we introduce the structural model inside of this architectural model. Okay, so coming back here to CYPECAD, we have the same numbers here. In case you want to add or apply any elevation difference between the architectural model and the structural model, we have this column here. So here you can add, for example, plus 5 centimeters or 0.5 centimeters to each level if you want to consider a difference between the architectural and the structural model. Okay, so with this information, we are generating new structural levels. Okay, so depending on the way the model is created, you can apply or not these elevations. It's up to you. In my case, I will not apply because I don't need that. Okay, but depending on your situation, you can apply or not these levels here. Okay, you can also decide which level you want to import or not. Okay, depending on the situation, we can have much more levels than this. Let's imagine we have a specific level because we have, I don't know, some part of our landscape have a lake or a garden or any other architectural element that is not related to our structural model, but we need that level because it's part of the architectural model. So here you can decide if you want to import or not one of these levels by clicking here. So if it's the green, you are importing, with red, you are not importing. Okay. One of the new features that was implemented is this new viewer here. We can see what information we are importing. So when you click, you can easily understand what is the roof, what is the railings, what are the rooftop. Actually, which elements are connected or are inside. I don't know how to say that to each level. Okay. So in the basement, we have those walls and those slabs. The ground floor, we have these elements here, including the columns. In the first floor, we have those elements and also the columns and beams. Okay, this viewer, it's new. It's much easier to be sure that the architectural model it's okay, even if you don't have CYPE Architecture in your computer or any other beam model that was used in your computer. Okay, here we have some features that are interesting. For example, you can activate and deactivate different layers here. So for example, using this button, you can activate and deactivate the architectural model. You can activate and activate the different furniture if you have, or even the sketch that was created behind the architectural model. This is a feature specific from CYPE Architecture. Here it's also available. You can manage the visibility of these elements here. Okay. You can also change here the background color, changing from white to gray to blue. Okay, different background colors, and you can also something here that is very interesting. You can click here in this button and consult the information that is here. Okay, you can click here and consult this information. You can also change from orthogonal to conic perspectives, different features that will make your work, your job easily, because you can inspect the model easily using these sections, these different filters that we have here. Okay, so this is now you can use also CYPECAD as a BIM viewer or an IFC viewer, because you can import the information and see what you have here. Okay. So the next step, we have the floors. In this case, everything is important to us. Let's jump to the next step, the columns. As we saw before, we have just one type of columns in this project. It's the rectangular 24 by 24 columns. Okay. So now we will start defining more information to these columns. Okay. We know they are a column with this format or this geometry, but we don't know the material. We don't know the real section of these elements. Okay, we don't know if you want, we can import or not these columns. Let's imagine we have different columns, and some of them were not structural columns. They were just introduced as part of the architectural model, but they don't have structural properties. So we could import or not part of the columns that we have in the project. In this case, we have just one type. Let's import, and let's define the cross section of these columns. Okay, so I'll click here, and then we open the traditional cross section menu that we have at CYPECAD. If you worked before with CYPECAD, I'm sure you already know this menu here, and it's here where we'll characterize these sections, selecting the materials and then the dimensions of these columns. Okay, so we have different options here. We can introduce, for example, a reinforced concrete section. In this case, you can see that the size here, it was imported or automatically imported from the BIM model. Of course, you can change it. Okay, you can also transform these columns that were imported from CYPE Architecture into circular sections, for example, or also change the material. For example, creating some wood materials, some wood sections, or some mixed materials with different combinations. You can also create your own material, adding the properties of these materials, this material. Okay, but in this case, we will work with steel cross sections. So here we have the library of materials, or the library of profiles that we have at CYPECAD. And if we are talking about columns, let's search for a nice rolled steel section. I think in this case could be something in I format, or this C format is not a good combination. So let's use this kind of section. Here you have all the families, different families that are available almost in all parts of the world. You can select the family that it's better to your project, or that is more common in your region. So I'll select this one, for example, and I'll select here one of the elements that is near to the same section that was introduced at CYPE Architecture. Let's imagine that this first section it's okay. So let's try with something near to the original values. I'll select this one. Okay. In this button, we can see the properties of this section. So it's a almost square section with this information. So let's accept, and let's assign this section to the column 24 by 24 that we imported from CYPE Architecture. From this moment, every column with this name will have this cross section in our structural model. Okay. Here we can maintain the references according to the BIM model. It means the name of the columns. We can maintain these names according to the BIM model, or we can automatically generate new references. And we can also define if we have external fixity or not. This will affect if we have foundations or not, or if we have columns that start in levels that are not in the ground level. So we can configure that. In this situation, we have both situations. So these columns here start on the ground level, and then we have some other columns that start one level above. So we must import everything with external fixity and then adjust these columns that are different, that start one level above. So we will do that operation during one of the next steps. Okay. So let's click here and let's go to the next window. This is a new window. Okay, this is a new window that was implemented in 2023 version. This is very nice because here we can import the walls. Okay, so as we saw before at CYPE Architecture, we have 4 types of walls: the basement walls, the facades type 1 that are here. Okay, these parts of our model. Then we have the facades type 2 that are those elements. Okay, and we also have the interior walls that are, of course, inside of our model. Okay, so here in this menu, we are importing those walls that we want to transform into structural walls. Okay, so in this case, let's suppose the basement. We will select the basement because we want to consider that these basement walls that were created at CYPE Architecture, they will be calculated, they will be designed and analyzed as reinforced concrete walls, or as plane stress walls, or as masonry walls. Okay, so we'll now the same way that we assigned some columns to a specific section, or better, some sections to a specific architectural column. Here we'll do the same with the walls. So we will assign a type of wall, a type of structural wall, to one of the walls that we imported from CYPE Architecture. Okay, so I'll consider the basement as the structural walls, and then I will transform the facades and the interior walls as loads. To do that, we will do in a second step that's going to be here in the construction elements tab, some steps in the next steps. Okay, here we can also open this menu here, and you can see wall by wall. Okay, so here we have the wall number 1, we have here the wall number 2, and if you want, you can import one by one. So if you had a problem with your architectural model, or if it was not clear when it was designed, so here you also have an option to select one by one. Although a good practice could be create classify these walls at CYPE Architecture or any other BIM modeler, considering that this group or this type of walls, all the group or all the types would be structural elements. So it would be much more precise and easier to import, but just clicking in one check like this, then selecting here the walls that you have in your model. Okay, but if you have that situation that everything is in the same group and you want to classify which one you want to transform or not, you can also open here and classify it. Okay. Okay, so let's go to the next step. Here we have the bins. Okay, 2 types of bins as we saw before at CYPE Architecture. Let's add some sections. In this case, going to be a bin, a steel bin. Could be a steel bin or a steel bin in a composite bin with those bolts, those studs. I'll use this one here. Okay, and I'll select here one section again. For example, I think I'll maintain this one, IPE 300, and I will configure here that the bin will start below this slab. So we will have the bin and the slab. Actually, as we see in this picture here, okay, the bin under the slab. This is going to be our model. Okay, so let's check this option. And let's do the same to this second section that we have here. It's a smaller section. Let's select here another one. Let's select, for example, it was 200. Let's select a little bit less, IPE 180, for example. Okay, so the same situation, the being below the slab, and now everything that was being 20x40, now it's a rolled steel IPE 300, and everything that was being 10x25, now it's a rolled steel IPE 180. Okay, we are adding more information, adding more structural information to the elements that were created before. We are not modeling. We are not drawing. We are not creating this information. We are just classifying, just adding more information that is related to this phase or this part of the project, the structural analysis. Okay, so let's keep going. Let's go to the next part. Here, just the floor slabs. The floor slabs, we have just two options. We can import or not the outlines of these slabs. Why? Because there are too many ways to create slabs at CYPECAD. We must use this information, these outlines, to define the geometry of the slabs. But there are many types of slabs at CYPECAD, and it's common to have different types of slabs in the same building. So here you import the geometry, then you can use this geometry to add more information using the panel manager that we have inside of CYPECAD to characterize, to select the best structural solution to each panel, to each space that we import using these outlines. Okay, so it's in this case everything it's important to us, the outlines. So let's import, and here the last one, the construction elements. As you can see, this is unchecked because when we introduced it here, the walls were considered as structural walls, the basement walls were considered as structural walls. But now the interior and facades, they will be transformed into linear loads. So we want to import this information. In some situations, as always, we could not import. It depends on the project. Okay, but in this case, we import everything, and yeah, that's it. So we have walls and construction elements. They are the same information as CYPE Architecture or the same information in our architectural model, but now we are classifying it in two different groups. Okay, the first one, structural models, and now just construction elements that can affect the loads of our model and also the seismic analysis if we activate the seismic analysis. We'll see in a second. Okay, so let's finish and let's wait CYPECAD working. CYPECAD is now generating a structural model with this information, considering all this information that we defined. So now we can see that 7 different floors were created, 72 different columns, 130 beams, 12 walls, 300 construction elements, 297 floor slab templates, and no fire sectoring. In this case, we didn't use it CYPEFire, but in some situations, we can also import information from CYPEFire and import the fire sectoring to analyze the fire protection of the structure. Okay, so let's accept. And here, I will not add too many details in this section, but here it's where we select the codes that we will use to calculate our building, to design our building. In this case, to concrete code, code from steel, rolled steel, timber, and aluminum. I selected the Euro code. Let me see here the Euro code. Okay, everything is going to be the Euro code in our project. And here we can also select the different materials of our project, for the floors, slabs, to the foundation, columns, the different types of concrete, different types of steel. We can activate here the wind loading, the seismic loading. We can check the fire resistance. So everything that is related to the code and the criteria that we use to design our structure, it will be defined here. Okay, so we'll accept that. Here we can set the limit states. Okay, so we can select according to the codes that was selected before. Here relates to the snow and also the combination for the displacements. I will maintain the default values here. I think to this example it's okay. And here we can also see again the same levels that we imported from CYPE Architecture. Maybe you can see that since we started, I'm just using my mouse. I didn't use the keyboard yet. So everything was imported just with clicks. Okay, just importing information. You have at these levels, everything was selected by clicking. So it's very easy to import this information. Here, it's the first time I will use my keyboard. So I will add here some loads. For example, in the railings, I will not add no loads. Okay, it's just an example. Maybe these loads are not the best. They are not perfect. Maybe I don't know if it depends on the use of and also the finishes of our project, but I'll add here some numbers just to have some loads. And the software is asking us if you want to check the construction elements that were introduced, because the walls were transformed in these construction elements, and now we must set the behavior of these walls. What will happen with these walls? Not those walls that are structural walls, but those walls that are construction elements. What will happen with that? So let's see. We have three construction elements, three elements that are not checked yet: the interior, facades, type 1 and type 2. So here we can set if these elements intervenes or not in the seismic analysis. So by checking this button here, we can set that. Okay, and then we can add all the information related to the seismic analysis that are the properties of this interior wall that we imported. And here we can also activate the surface loads. So here we add a number that's going to be kilonewton by square meters that will be then transformed according to the height of the building, the wall, in linear loads. Okay. Here there's a nice button that we can use to assign some values. For example, it's a help that we have here inside at CYPECAD. So I can select here different types of walls. So the interior wall, for example, I use this option, internal partition. I can select here different materials and the type of mortar, type of joint. So I select here one specific wall, I accept, and these values are updated. So here we know the surface load. We are adding the surface load to the interior walls. Okay, let's do the same to the facades. For example, in this case, I will use an external wall, and I will use the same to the second one. Probably they are not the same, but yeah, just to simplify, here you can see that this is a little bit heavier than the interior walls. So now we have everything with the loads introduced. Okay, so let's accept, and here we have the model. Actually, here we have a very good model. Of course, we must add the foundations. We must add the slabs. But let's see what information we imported from CYPECAD, from CYPE Architecture. Okay, let's use this button here. Let's just save. Let's use the 3D view of the model, and let's see what we have here. In this first moment, okay, not too many information was included. We can see that here in the basement, we have in this light brown color, we have the structural walls that were introduced automatically. Okay, this is one of the new features of 2023. We can also see in the red color that the columns were introduced, and also in the green color that the steel beams were introduced. Okay, those planes, those green planes, they represent the construction elements that are the interior walls and the facade walls that we transformed. So that we introduced the loads to those elements. Okay, so this is the model, and as you can see, the foundations and the slabs are missing, because now we must select what type of slabs and what type of foundations we will have it. Okay, so let's start. I'll go to the basement level, and I will start adding some footings to these walls. Okay, to do that, I will edit the walls that were introduced automatically. Okay, and I will select the type of foundation. For example, strip footing without soil structure interaction. For example, there are other options here. Okay, I'm just selecting one to create an example. I will do the same to all the elements that we have here. Stripe footings, this one too. As you can see, automatically, based on the information that is by default here that we can change, we are adding the footing, the linear footing or the strip footing to our walls. Okay, so let's add another one here, another one here, another one here. We are almost there. So based on the geometry of the architectural model, we are creating our structural model. Okay, And now we have all the basement walls with the foundations introduced. We can also see that the columns, they don't have any foundation. So let's add some elements here, some foundation elements. Let's select the type of elements, for example, square footing, or I don't know, different. Here we have different elements. Let's suppose they are squared. So I'll put one here, another one here. Don't worry about the size of these elements, because when we design the structure, everything is going to be calculated and automatically designed. So it's important to add the position. So in this case, I'm just adding the default values of these footings. Okay. If we see the 3D model at this moment, we'll see that in the basement, everything is okay. Okay, so let's go to the basement. In this blue color, or almost purple color, you can see the footings, so the foundations under the columns and also under the walls. Okay, so the footings are introduced. But as you can see, if we use one of these views, for example, this one, these columns, they are flying. We don't have the footings here. So as they are in a different level, we must define the fixity of these columns before we add the footings. Okay, so to do that, I'll come back here to the column definition. And for example, this guy here that I know that is flying, it's in a level above of the basement. I will edit this guy, and I will change this option from without external fixity to with external fixity. Okay, I can see here in this scheme how this column is where it starts and where it stops. Okay, so accept that, and I will copy this information, this property from this model. So I will copy the fixity coefficient in this case. So I will copy from here and assign to these guys here and also to these guys here. Okay, so let's finish that. And now I can come back to the BIM definition tab and finish introducing the foundations. I am now in the basement. So let's use here our lift, our elevator, and let's jump to the ground floor. Here in the ground floor, we have the different columns. Okay, so let's add some foundation elements. Let's select the same foundation elements that we used before, and let's add here some footings. Okay, here, 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 and here. Okay, yeah. So everything that is related to fix our structure in the soil, in the ground, it's ready. So now we must define the slabs, for example, or the panels of our project. You can see that everything now it's with this interrogation point or this symbol, because the software know that probably here we will have a slab or any type of slab. So this information is missing because the outlines were automatically imported from our BIM model. So let's define these spaces. So here in the slabs, in the panel manager, it's a steel structure. So I'll create a steel deck or something like that. I think here in the composite slabs, here we have form decks or composite deck. I use this one here. I don't know if it's the best one. Let's see the dimensions here. This is the thickness. Yeah, we can also personalize it. We can create our own dimensions, or we can import from the library from the software. So yeah, I'll use this one, and I'll select this panel here, and let's introduce the first one. Okay, so the first one was introduced. And let's zoom out a little bit, and let's copy. Let's use this button here to copy this panel and apply to everyone here. Okay, so now we have the steel decks or the composite deck introduced on the ground floor. If we go to one floor above, we'll do the same. So let's use the same composite slab. Let's add here. Let's copy this guy. In this case, I will introduce it here. Okay. As you can see, maybe in this panel here, it would be interesting to rotate the direction of the panels, because this dimension is smaller than this. So I will use this guy here, change the layout. So I click here and I will change here because it's going to be better to design this, to distribute the loads in these beams. Okay, for example, let's do the same here. And here we are almost finishing. All right, so as you can see, I don't know how many time we spent, maybe half an hour, explaining how it works. Okay, so if we were working, actually working as in a real day, it would be much faster than this. But if we go to our beam model, let's see what we have here. Let's see what we made with just some clicks. Yeah, here we can see that the footings are okay. Behind it, we can see the panels of our steel deck or our composite deck that were introduced in the ground floor, also in the first floor, and of course the second and the roof floors are missing. The process is similar. Okay, the process is similar. It can also copy information from one floor to another. Just to save time, I will not finish that because the process will be the same. Once we finish the introduction of these elements, we just have to analyze the structure using the options that we have here. Okay, so we can include the foundations or not in our analysis. There are different criteria to select how the sections are designed. For example, we can design just using sections greater than the sections that we have, or using all the sections of the series, trying to optimize the design. Okay, we can also, when we are working with composite floor deck slabs, we can design the thickness of the deck or not. In this case, it's just a form deck, okay, with no structural. The plate or the steel plate is not a structural plate. Okay, so I have this model in a most advanced moment. Let's say. So after starting the calculation or the analysis, we will need at least 3 minutes to analyze everything here. So to save that time, I already calculated the same model before, and here I can show you how is this result. Let me show you the same model with that information. Here you can see the model is complete. Okay, here we have the sections designed. The stairs are missing. Okay, we should spend a little bit more time and also add the stairs. But as an example, I think it's a good example. Okay, sorry about the stairs that we don't have today. Okay, maybe in the future we will add the stairs here. Although CYPECAD now also export the rebars of the stairs. Okay, in this case we don't have the stairs. Okay, here in the results tab, it's nice because we can also see we have here some options to select what information we want to see in the 3D view of this model. For example, we can view the joists, the lattices, we can see the forms. If we have post tension and stand-ons, we can also configure to see or not those elements. And once we configure that, using here also the group options, the group menu, in the 3D view of the building, 3D view with details, we can see the reinforcements or the rebars that were generated. In this case, we have rebars just in the walls and the footings. So the steel elements don't have rebars, but let's see what we have here. Let's see, because this information, we will also export this information to BIMserver.center. So let's zoom in. Here you can see the details of that. So yeah, here it's the rebar of the footings. And here, for example, the rebars of the walls. This is another new feature that was implemented now in the version 2023. The rebars of the walls, they are automatically generated, and we can now export it to our beam models. Okay, so yeah, these are the models. I think here we have some filters. Let me see. Yeah, we can activate and deactivate the different reinforcements. and the different elements. Okay. Here we can see the panels of our slabs. Okay. Yeah, it's a nice way to inspect what is happening here in our model if everything was generated as was planned. Okay. So now we know that everything is okay. It's time to export this information again to BIMserver.center. Now adding a second discipline, a second layer of information. So we have the architectural model and now also the structural model. Okay, so we will use this button here. We are connected to the same project. This is my profile. I'm connected. So let's use the BIMserver.center menu, and we can share information with our colleagues or with other software that we are using in our own computer. Here we can set different things. For example, we can set how the columns are generated. We can set if the column is situated, the end of the column is situated between the bottom surface of the floor slab and or the beam the floor above. It means we can set where the column ends, if it's in the top of the slab or in the bottom of the slab. Okay, we can select if you want to share or not. In this case, the panels of these composite slabs that we introduced in the project. We can select here different type of colors. We can click here, and with just this click, we can export the reinforcement. It means the rebars that we saw before. We can export the analytical model. We can export this option here. This option is very important. Export forces to design connections. As we have steel structures, we have steel elements, columns, and beams, and we want to calculate to design the connections using CYPE Connect, we must export this information here. If we check this information here, when we import this structural model at CYPE Connect, all the forces will be imported in the exact places where they are acting. So it's going to be much easier to design the connections. Okay. So yeah, the software it's exporting, it's transforming this structural model in an IFC file and also some complementary files that will be used to then in the next steps. Let's wait a little bit. Okay. So yeah, here we are obtaining the forces to design the connections and generating the different elements. Okay. Of course, this information, we will add this information to a third step. So we will jump to CYPE Connect, but you can also come back to CYPE Architecture, update the model, and download this information at CYPE Architecture. Okay, so now it's a good moment to check if those sections that we implemented in the first moment were okay. So if those sizes were okay, and if not, maybe it's a good moment to update the architectural model according to the sections that now are checked. Okay, so because maybe those elements will interact with other elements. For example, the curtain walls could be connected to the columns, or maybe I don't know, the beams have some sizes that are not where you cannot put a window, for example, because the beam is too high. I don't know, something like that. As you can see, the structural model now it's finished, so it's exported. It's uploading again to the platform. We are working locally, so let's jump to CYPE Connect. Okay, CYPE Connect version 2023A. Let's create a new project. The same process. Let's link to the same project, and let's import now the structural model. Okay, so we are connected to the modular building project. Now the CYPE architectural model doesn't matter to us, but the CYPECAD model, the structural model, yes, this model it's important to us. So let's click here, and an important button, this button here, generate nodes automatically. Okay, so if you are using any other software that is not CYPECAD to create your structural model, any software that generates IFC files, you can also import these models here. And with this option here, you can generate the nodes automatically. Okay, so let's click here, and let's see what happens with this model, this structural model inside of CYPE Connect. as you can see, everything here it's very fast. Although it's a structure with, I don't remember, 72 different elements, 70 columns, it's very fast. So CYPE Connect imported here different elements. Okay, so different profiles that are HA2400A, so the columns in this case, so 286 different elements. And inside of our library, we have those profiles. So automatically, the profile that is here was assigned to the same profile that was found in the CYPECAD model. So you could also change it again, but normally you not change that. Okay, normally you use, of course, the same model. But in case you wanna check another profile or you are just doing some manually checking, you can change it. You can also decide if you want to import or not. Okay, but in, I don't know, 90% of the situations, you just import everything as we have here, because the same sections will be here, and you import everything. Okay, so let's accept, and let's see what we can have, what elements we have in our interface of CYPE Connect. So the software is preparing the work environment. And here we have a kind of analytical model of our project, okay, with a lot of warning symbols here because the connections are not designed yet, okay. We can see here, we can click in one of these elements and it would be highlighted here in this list, or we can click here in the list and to see the software, the elements in the 3D environment. Here, there's a nice, interesting feature. I think it's here, where we can change the section representation from axis to 3D model. And we can see the sections in the real size, okay? So now it's a little bit more similar to those appearances that we had at CYPE Architecture. Here you not see the concrete or the reinforced concrete elements because we are talking about connections. So here you cannot see the walls, although you could import, let me see here, there's a way to do that. I think it's gonna be here. So here you can import here the structure reinforcement, for example, just to have an idea about the sizes and the appearance. So let's activate the reinforcement. Yeah, here you can see the reinforcement, the walls in this case, okay. And in most situations, that's going to be too many information to have in a computer that will be analyzing, designing connections. So it's going to be useful to turn off these layers that are not in this moment that not affect our calculation. So for me, at this moment, the reinforcements are not important, not yet. So let's select one of these connections to calculate. For example, this connection here. The software introduced one connection. Let's check what happened with this connection. This connection is created, it's the connection between two columns, the column P2 and the column P1, okay? Yeah, I can design a connection for that combination of bars, but I wanna create something that is more complex. I would like to add every bar that is arriving in this node to the same analysis. So I will delete this one that was automatically generated, and I will use this button here to create a new node. Okay. So I will, let's wait a little bit. So I'll select this bar, this bar, this bar, this bar, also this bar, and this bar. Before we select the last one, here you can see that's information that we defined when we exported the model. So we selected that the column finishes at the top of the slab. Okay, so here you can see that. So let's select here and confirm. And now we have the P1, the P2. We also have V1, V2, V3, V4. Okay, so 6 different elements that are part of this node that will calculate. Okay, we'll design it. So yeah, here we have a node, a new node. Okay, here we have this new node. All right, so that's the symbol, the node is there. So let's start design this connection. Okay, I will not design the connection 100% here because yeah, that's not the purpose of this software, this presentation. So there is an interesting feature that we have here that is the library. Okay, so I can import elements and export elements to a library. Okay, and this library we can save it in our computer. So I have here two different combinations that I've created before to these sections. So the section 002 is this one here. Everything it's bolted, okay, with those plates and welded plates to connect the elements. And the 001, it's similar, okay, is this one here, okay. I'll select, for example, the second one, 002. Let's accept. So now it's imported to our library. So let's import to this node, 002. And let's see what happens. Automatically, these operations were introduced here, and the elements were introduced. Okay, so this is part of a previous work that I made, that I saved it, and now I'm using that. Just to have an idea what happened here when I created this this connection. So some profiles were adjusted. Let me see if I can link here. Let me see if it works. No, I have to unselect everything here. Yeah, I'm using too many softwares in my computer at this moment. Yeah, I will just select just to show that some profiles were adjusted, that some end plates were added, then some bolts. So the different operations here were introduced with these buttons to create this combination of elements. Okay, we have some seminars, some webinars in our channel. Okay, and also some tutorials and some and we also have a quick start guide to learn how to create these elements. Okay, just search for CYPE Connect at YouTube. You'll find a lot of videos that we've created and published about this part of the software. Okay, once we have this element, the next step is analyze this connection. Okay, analyze this connection, and here we have the new feature that was introduced here at CYPE Connect, that is the rotational stiffness. Okay, so until the last version, we calculate stress and deformed shapes. Okay, different analysis and code checking according to these parameters. But now we also have this button here that is the rotational stiffness. Okay, we need here around 3 minutes to calculate this connection with this option, and then a little bit more with this one, 4 minutes. It's not a simple connection. We have here 6 different elements, a lot of welds and a lot of bolts and a lot of plates. So yes, again, I have this element calculated. Let me jump to the same model, but with this information calculated, just to save some time. Let me show you. Yes, I have it here somewhere here. I think it's this guy here. Yeah, it's here. Let's open. Just to show you some results and how this new feature works. Okay, so it's exactly the same connection. And here you can see that the color is different because we already calculated. okay? So in our elements, we have this scale from 0 to 100. It means that if we have some elements that are in red, they are outside of the range to the resistance range, for example, or any other parameter, for example, the deformation range. And here we can see all the checks that were made according to the code that we selected. In this case, I think we selected the American code. Okay, so here you can see that, for example, the bolts have this result to this load case according to this check that is part of this code. Okay, so we can select. We can also select one element here and see the checks that were made in one specific element. Okay, and although here we don't have problems with the demand capacity ratio of the elements, I see here that this symbol is showing us that some checks have not been verified. So using this button here, we can see for each element which elements that failed. For example, on the plates, we have here some parts, some points of the code that does not check. Okay, so for example, here this edge distance is not okay. We should now change the model and design it again. Okay, I will not change that. Okay, it's just to show one example that the results, how the results will be shown to us in the software. So you can see according to the color how far the elements are from the failure. And here using the checks, the steps here, you can click on the element and see what checks were made and the results of each one. Okay, so these were the checks and the results are here in this panel above. Okay, in the bottom. Okay, so but everything here it's related to the stress or to the deformed shape. Okay, so this first filter, this first view that we have is the maximum demand capacity ratio, but you can also activate the von Mises stress. So when you have a problem, when you have something that is not well designed, maybe using the von Mises stress, selecting the load cases, you can try to find where the stresses are concentrated, and maybe then you can redistribute the elements, the bolts, the plates of your connection, trying to a better design. Okay, this is a very nice view. Here, there are some filters. For example, you can change the contour plot representation from discrete to continuous. You have something like that. Or you can also change here the maximum and the minimum values that you represent. Here we can see that we are going from almost 0 to 247 megapascals. So let's suppose that everything that is more than 150 megapascals, it's red, it's the maximum. So then we have this situation here. So everything that is red, it's more than 150. So you can use these filters to find the critical parts of your elements, changing these values. Okay. If we deactivate, we'll come back to the default values with the full scale. We also have here the equivalent von Mises deformation. It's going to be the same situation. You have also the same filters and also the displacements. Okay, here are the displacements. If we use one view like this one, or maybe this one, and we'll apply here a scale that's much bigger, for example, 10, we can see the displacements of the bars. Okay, this is part of the software. This part of the software was introduced during the version 2022. Okay, but as I said before, after calculating the stress and the deformed shape, we can also calculate the rotational stiffness. Okay, how it works? First, we must select which bar we want to calculate the rotational stiffness. And to do that, we use this option here, the load cases, here the loads. Okay, we will select, as was in the previous versions, one element as the bearing, for example, the P2. Okay, and then, for example, here to the V1, I selected that I want to calculate the rotational stiffness of the V1. Okay, and here inside of this option, I can see that the forces that were calculated there in CYPECAD in the past, okay, the momentums and all the shear forces, axial forces that were calculated according to a specific load case that was also generated automatically at CYPECAD. They were imported here, and now I can calculate the rotational stiffness of this element. V1 and V2, V3, for example, are selected. For each bar that we want to calculate the stiffness, we must select it here. Okay. Another information that was imported is it's the size, the theoretical length of the elastic bar in both planes, Y and Z. Okay. So these numbers, we have spans of 4 meters between axes in our project in both directions. So here, discounting the size of the sections, we have these numbers. Okay. So those numbers were automatically imported from the BIM model. Okay. Why we need this information? Because here, to calculate the rotational stiffness, we will need to know the length of these bars. Okay. So if you change the size of your section here at CYPE Connect because you are maybe trying another combination without updating the main model at CYPECAD, you must remember to change the theoretical length here, because according to the size of your model, maybe this length could change. Okay. So this information will be used to calculate this rotational stiffness. And once you select which sections or which bars you want to check, you just have to press here on the rotational stiffness. Okay. I think this is already calculated. Yes, it's already calculated. So here you can see that for V1 and V3, I have some results. Okay. Sorry, it's not here. So for V1, for example, I can see that the size, the length is this length here. Here I can see the different results, and according to these results, the software will classify if it's a semi-rigid, or flexible connection. Okay, so here you can see pinned connection. Sorry. So if we have numbers or results that are between this line and the blue line, we will have a pinned connection. It's going to be connected according to the design that we do here. If the results are in this range, it's going to be a pinned connection. If it's between 3 and 1 in the 2 range area, we will have semi-rigid connection. And if we have results between 1 and here, we will have rigid connections. Okay. This graph we can see here. So for example, this one is classified as semi-rigid. We can see that just going here to the start, that the limit, one of the limits is here. I think we can open this in a new window. Let me see. No, I think it's not possible. But here, the purple line, it's the first limit. The orange line is the second limit, and the blue line is our situation. It's our result. So we are in the middle, in the second range. So we have a semi-rigid connection. Okay, this is the first, the V1, and the V2, it's similar. Okay, actually here we have some results that are very, very similar. Maybe just some forces that change a little bit from V1 to V3. Okay, we can also see here the different load cases. As you saw before, we didn't introduce those load cases. They were automatically imported from the BIM model and generated from the BIM model, as the button says here. Here you can define how this information is generated. And when we are talking about the rotational stiffness, you can select if you want to generate the forces, just importing the maximum moments with simultaneous forces from the CYPECAD model, or for example, the maximum moments without the other forces, the maximum moments by plane with simultaneous forces, everything or none, because maybe you want to introduce some manual forces to check any other parameter that you want, any other type of force, or you're just manually checking. So you can set to not import the momentum to analyze the rotational stiffness. Okay. Let's suppose everything is okay. We know that in this case, some of our elements are not according to the code, but let's imagine it's okay. We can jump from the analysis to the sheet and generate all the drawings, the importing, everything here. We also have some tutorials and some seminars in our channel that you can check how to work with these sheets. okay? But just would like to show you that we are using information from other parts of the software. From the architectural model, we have the structural model. From the structural model, we have the forces and the geometry of our node. And now we design it, the connection, we check the connection according to a code. And now we can also extract the graphical information, the plans, the drawings of our elements. So everything is connected here. We are optimizing every step that we make here, okay? And of course, you can also introduce this element in your BIM model, okay? As you can see here, it's represented, and we can also share this information. So here I will put here a new file, or create a new IFC file with this information, connections, and I'll export this information back to my project, okay? To my project, and I'll come back to the beginning to close the cycle. So I'll come back here to CYPE Architecture, okay? And I will update the information, and let's see what will happen here, what is happening. So we have the CYPE Connect that was generated now, the CYPECAD that we generated before, and the other files that were already there. So let's accept, and let's download this information at CYPE Architecture and see this information inside of our model. So we are reading this information. CYPE Architecture is reading this information. First, the structure. We are also sharing this information with our project at BIMserver.center. So if I jump here to my account, let me remember where it was here at BIMserver.center in my project. The project's here. And here in the history, we can see the last changes. Okay, just some minutes ago. And here we can see the contributions, my contributions to this project. So yeah, I add the architectural model, then the structure. We add in another moment the construction systems and LTO model, and now one of the first connection. But we should add those connections in the other nodes to finish the design of our structure. Okay, let's come back here to CYPE Architecture. It's already done. Let's deactivate here some layers of CYPE Architecture, and let's see what we have behind it. And select, let's see, and select this guy, this guy, this guy. And let's see what is happening here. We see one node that is there, but we can activate here other models. For example, the structural model. Look, the structural model calculated with CYPECAD, okay? And somewhere, I don't remember which one is here, and maybe it's behind the slabs. Let's put the structure in transparent to see. Here it is.
Yeah,
here we can see the connection, in this case, integrated to our model. So just to have an idea, for example, let's imagine here that we activate the furniture, just to contrast information. We don't have furniture in this level there. We don't have furniture here. It was not a good example, okay? But just to show how everything is integrated, everything was used from one step to another, so optimizing your workflow. And as I said before, you can imagine that I could be here working with CYPE Architecture. I could invited Marta to this project, and Marta could be designing the structure or the connections with other softwares in the same project at the same time. This is maybe one of the best parts of this CYPE ecosystem that is integrated through BIMserver.center. Okay?
Yeah. Fantastic.
Marta, I think we have been talking too much, 1 hour and 15 minutes or a little bit more. I don't know if you have any other comments, if you have.
No, but just to thank you for the presentation. It was really interesting, to be honest. And I just wanted to remind everyone to my email address, just in case they want to send any questions that they haven't been able to do it yet in the chat. or if they want the link for the recording as well. So because maybe some people joined us a bit later and they couldn't see my email address.
Maybe you can share your screen and you can show your information again.
Yeah. So I'm gonna just show this slide where it says your name and my email address, marta.franca@cype.com. So send me anything you need to that email address, please. And I also wanted to remind people how to get the software from our BIMserver.center platform. So you log in or register, which is free, and then go to our store, which is this, and then you can find all the programs here, but you can search for them here. So you can put CYPE Connect, for example, and you can see it here. And then when you find the program you want to download, you have the button here to download it, but also you have this button here on the left, where it will take you to the website, and you can find there all the information you need, even to download it, about this program. Like here, as Afonso said earlier, you can find the learning resources, which are all the videos, tutorials, articles, and everything you need to learn how to use the program or to start to use the program. So this is for CYPE Architecture, but you can find it as well for CYPE Connect if you go to the application website, as you can see here.
Actually, those tutorials I have been talking before, they are here. Okay, you can find those tutorials on the learning resources of CYPE Connect.
Exactly.
There's a library of videos and tutorials here.
So you can find them here in video tutorials, and you can find the different languages as well here. These are in English, of course, but you can find your own language if you want. Mm-hmm. And that's all I wanted to remind everyone. So for me, that's okay. So I just wanted to say thank you to everyone for joining us today, and good luck.
Thank you, Marta. It was a pleasure to share this session with you. Thank you very much for everyone that have been with us during this hour and almost a half. I hope you enjoyed. I hope you learned a little bit about this amazing software that we have here. And remember that tomorrow we have the last session of this seminars related to the version 2023. We will see how to create the landscape of our project. We will see how to create an IFC with the topography model of our project using one free tool that also connects with all this ecosystem, this free tool that is called OpenBIMsite. Okay, so tomorrow we'll see this information. So if you are interested on that kind of topics, tomorrow we will have at the same time. It's our fee, just have to join us at the same time. Okay. Thank you very much, and see you.
Bye.